Hello everybody and welcome to this automotive technology video on domain controllers. Today we have a very cool topic. We will talk about advanced jitter analysis for domain controllers. For this topic, I have invited my colleague Matthias Helwig. Hi Matthias.
Hi Nick.
Thank you very much for joining me in this cool video. And of course, when we are talking about high-speed digital interfaces like USB 3.0, HDMI, SerDes, very important for automotive, PCI Express, jitter analysis is very, very important. So, what have you prepared for us today?
So I've prepared for you a PCI Express compliance setup, just as a demo vehicle, to show you the cool advanced jitter features that we have built into the RTP. Let's have a closer look to the setup. We have here a PCI Express Gen 3 compliance baseboard that has the riser card. Then we have the domain controller, the 4 lanes PCI Express connected to the compliance baseboard. We have here 6 termination resistors for 3 lanes. And we have for lane 0, P and N terminated by the oscilloscope here. And using the toggle button, we already have selected the preset 0 for the PCI Express compliance. The advanced jitter analysis of the PCI Express signal requires a lot of configuration, and I will guide you through this configuration, and we will see multiple results, and I will explain what the results mean in regards to this analysis. Let's have a closer look. So now we see the P and the N channel. The P channel is the channel 1, the N channel the channel 3. But this is not what we would like to analyze. We would like to analyze the differential signal. So let's create a true hardware differential signal. So basically I open the channel menu, go to differential signal, select for the difference to channel 1 and 3, and press enable, changing it to the right scale, which is in this case 100 millivolts per division. This gives me the right differential signal. I basically can put it in a different window. I also simultaneously see the common mode signal. It shows me here that I have a pretty perfect signal, no common mode disturbances. This can be a very valuable information in case you have common mode disturbances. That will create a lot of errors and also EMI problems, but for this time there is no. Let's close the P and the N because I don't need that. Next thing, before I turn on the jitter, I have to make up my mind how much information I would like to record per acquisition. In this case, I think 20 microseconds is a good value. What is the reason for selecting this large acquisition? If we go to the periodic jitter later on, I need at least acquire so many data that the sine wave of a periodic disturbance fits into my acquisition length. So here we have 20 microseconds per division. That means I can see disturbances, PJ disturbances down to 50 kilohertz, which is typically in the range of switch mode power supply. So this is a good value here. Now let's turn on the advanced jitter analysis. I see here already that I have to change the channel to the differential channel. And then I can go configure the software CDR that we require. We have a preset button for PCI Express Gen 3 that basically makes the configuration easier. And you see already the right settings. We have a second order PLL, and also the bandwidth is configured correctly. So let's go back to the advanced jitter setup. Going to the next tab, which is the decomposition tab. I basically add a few more components which I would like to see. We have the DJ delta delta for the dual Dirac estimation. Very important, RNS doesn't rely on the dual Dirac model. We have a different way to do that, but we still offer this value for customers and for compliance reasons. If you check for compliance with the oscilloscope, you can use that. I also turned on the ISI and the DCD. Our approach to advanced jitter is essentially based on the wireless communication. So we do a channel estimation. As we do the channel estimation, we basically need to know what a good step response is, which comes out of the channel estimation. For the moment, we leave it here at 20 UI. And now we can go to the result page. You see here, I have various ways to display results. So I like to see histogram of all jitter contributions. It could be interesting to see the track of the total jitter and the spectrum for RJ, TJ, and PJ. Then I would like to see the step response. This is something new. And the bathtub curve. Once I've done that, I basically can enable that, and the oscilloscope will calculate the results. So here are the results coming back. I pushed it to a run single. Now, as the oscilloscope has acquired a single acquisition, let's have a look at the details. There are so many results, but the smart grid will enable us quickly to rearrange the whole setup and have a better look to the results in a closer shot. So I rearranged the whole setup. You see here at the bottom the histogram. You see basically that in gray is the total jitter. It's dominated by the data-dependent jitter, the DDJ in blue. We have a small RJ contribution in red and a very small PJ contribution. You see that the calculated bathtub curve looks fine. We are going down to 10⁻⁵ roughly. And also the jitter values are presented here. You can display it either in time or relative to the unit interval. But these seems all to be fine. Now I go to the next tab where I rearranged something which is new. I introduced the step response as an important measure for the channel measurement. So this gives an estimation about the channel from the DUT, from the chip, via the domain controller, via the baseboard, the compliance baseboard, and the cabling. You see that there's kind of ringing, which typically is inferred by the press fit connector of the PCI Express Edge connector. And you have a good way to analyze that, for example, using the cursors. So selecting that, going to the cursor, for example, you can go ahead and measure rise and fall time. By doing that, you get an idea about the channel bandwidth based on the step response measurement. You see the results, and you also see a frequency here at the bottom, which gives you an idea about the channel bandwidth that you typically have. As you can see, the advanced jitter analysis gives you a quite comprehensive idea about your signal, and using then the step response as a new feature for RNS will give you a detailed idea about your channel, which is typically not visible in your advanced jitter measurements. The advanced jitter analysis of the RTP of Rohde and Schwarz is a very powerful tool. It requires quite a bit of configuration, but it rewards you with a lot of signal details that you really need to understand your design and interpret the results. I think if you get used to that, you will like it.
Matthias, thank you very much. That was indeed a very cool and detailed demo that you did there. And I really liked how we can separate now the jitter. You can have all these different jitter elements, very important, especially for engineers, who are trying to do design of domain controllers and high-speed digital interfaces, but also the step response that you can see how the signal can be affected when you have a change on impedance sometimes. Yes. Very, very cool. Thank you very much for the demonstration.
You're welcome.
So, on behalf of myself and Matthias Helwig, I would like to say thank you for watching this video. Please make sure that you go to the Domain Controller Solution page for more information and how to make your life easier with our test and measurement solutions. Stay healthy and safe. We will see you next time. Goodbye.